It works. I'm 2 bytes off. That's ridiculous. Why 2?
Where are the pots?
The what?
All the pots for cooking. Put them in here? You did. Why put the pots in here instead of cleaning them properly?
I don't know. I am 2 bytes off. The parent blob is the same. And value 657. Parent blob is 100. Parent blob is 100. Value is the same. Parent blob's the same. This is 838, and that goes to create the pointer. Parent blob is 530. Pointer it creates is 97. Okay. So parent blob. Oh yeah, that's what I screwed up. This is what I wanted to do. Oh, and I forgot what I wanted to do again. Oh yeah, so here create blob pointer. That's probably what's wrong. Yeah, that's the problem right there. So when I resolve pointer, I resolve it from the beginning of the blob, not from the beginning of the blob header. So I just need to convert this to UTF get blob, and that should fix it. Well, that's a different breakpoint anyway. Making progress. It returned 12. What's the problem? Oh, it's the line before that had the, of course. No, that one's fine too. That's 13. Everything's cool. This returns 12. Everything. I don't get it. Assert failed string comparison. The line numbers must be wrong. Rebuild. Okay. Let's start the stream for real. Yeah, I don't know why it's doing that. That's weird. So let's start the stream for real. I'm going to stash what I'm working on now. There. And rebuild it clean. Okay. So, oh, thank you. So today, I'm working on a reflection system, and I thought it would be fun to do a little more work on the reflection system, like a printing function. So I'll explain all in all what that means. We'll start from the beginning for the benefit of people who are watching on YouTube or something later. So let's see. Let's close a bunch of stuff that doesn't matter. And open. Where are my tests? This file. So I'm making a reflection system. A reflection system is a way for your program to say, okay, if you have a struct, then what fields does that struct have? And you can iterate over the fields of the struct or iterate over the structs in your program just like you would iterate over the items in a list. But C and C++ don't have reflection built into the language like most languages do. Honestly, all of the new languages do. C and C++ are old and they don't have it, and the standards committee is not going to get it in there anytime soon. And so generally when you want to do reflection, so hold on, let me give an example here. If I have a struct, okay, and another struct, and let's say I have some stuff in the struct, I have some properties. So at some other point, I have some kind of function, and I want to be able to say, let's see, a class. So this isn't an instantiation of A right here. It's a new A. That's not what we're doing. This is the metadata of A. It contains what is A about, like what's the stuff in A, what are the fields of A. So if I have a reflection system, let's say I have a magical reflection system that lets me get the information of A, then I might be able to do like this. For all of the fields in A, I want to, let's see, print the name of the field. This is an example. Okay, get fields, give it the index, and then say dot get name, something like that. okay? And then this program would print out A and then B, because the name of my fields are A and then B, right? So this is a reflection system. And so you can use this if you're making a video game, for example. You can use this to save all of the data in your game, because you have your player class, you have your monster class and whatever, and they have health and they have fields, and so you can just loop over your fields, and instead of saying printf, you write it to a file, right? You say fwrite the name of the player to the file, and then write its health, and then write everything, and then later you can read it all back in. I guess this would be fprintf, but you get the idea. You can read it back in and repopulate the fields, and so this is what a reflection system is useful for. You can also use, tons of uses. You can use it to like you need a reflection system to know what kinds of fields and members you have, so that you can send that data across a network if you're doing a multiplayer game. So, for example, if you're the server programmer and you see, oh, the player has updated, he's used some of his energy, then you have to send that to the client so the client knows, and so the client can print the new value on the screen of how much energy that they have. So reflection system's useful for that too. The reason I decided to make a new reflection system was I realized that a lot of the problems you solve when you're making a reflection system are the same as when you're making file formats. Okay, so going back to my example. So here we have a struct with some, these are my test cases right here. We have a struct with some data in it, and we want to save that to disk, and we will want to load it again. And then maybe in the future, I might have a new version of this struct that has an additional member, and some of the properties, some of the fields are reorganized. So I would like a system that can save the old version. So let me give a more concrete example here. You have struct texture, okay? And this is a texture format for your engine. So let's see. So it has some fields, width and height, right? And it might have a depth field, okay? And then of course it has the data. So then this is the texture format you use. This is all you need to know. You know the width and height, you know the channels, you know the data. But then later you decide that you want to add a new option to this thing. A compression level. Okay. Well, you already saved a bunch of textures with this format. And now you're adding in a compression level, but you don't want to have to go to the game that's sitting on your hard drive and update all the textures. You would like it so that the textures that you wrote out before, you can just read them in, and they're still valid. So so this is what a reflection system does for you. So that's what I've been working on. Back to my test case. Where'd my test case go? So you have different versions, right? And you can see A, B, C, E. It doesn't have a D, but this version does have a D. And then we'll go to the writing code. Where's the code where it writes? Right in here. So test versioning. So I can write out A, B, C, and E. I write that out to the disk, and when I read it back in, I pretend it's the newest version, and the reflection system will do this versioning for me. It will map the old values to the new values, and it knows where everything is, even though I'm looking at the the old version in memory. The reflection system sees that I want to access it as the new version, and it just brings up the new version straight away. So that's what we're doing here. Questions, if you got them in the chat. I'm gonna start, let's see. I'm gonna start by writing a print function. So it'll look something like this. I have a print instance, you give it an instance of a struct or a collection of structs that you want to print, and actually I think that should do it right there. That'll be our signature. You gotta find a good place to insert this. Let's put it. Let's put it here. So for debugging purposes, you want to print the data because what's in the reflection system is pretty opaque. It's not visible by the debugger because it's just like flat data, so it's nice to have some kind of function that you can print them. Okay, so let's take a look at the storage of all this data. So we have a reflection system. It's got a number of structs and enums in it. That's as far as I've gotten, just structs and enums. Each struct has a number of versions. Each version has a number of fields. Each field is a type and a name and some other information for like whether it's an array, what type, you know, what, all this stuff, and an offset into the field. So if I have a bunch of data, each field is gonna own an offset into that data, and then the data for that field lives at that place. And then this is the data that's in an instance. So an instance is like a handle into the data that you want. It has the version number that you want to access through. This is actually obsolete code I'm going to delete, so not worrying about that. It has a list of allocations that the reflection system has made in order to create your object. And then a pointer to the start of the object. So that's what we want to start off with at first, I think. So let's see. So let's grab that private data, and a blob is literally a blob of data that the reflection system has stored. It has all your data in it. So we're gonna grab the top level blob, and this blob will, in this case it'll be a struct, and it will point to all of the other data. So there's my blob right there. So in this case, we know that it's going to be a struct because the top level blob is always a struct. So I'm going to get the struct header. So let's take a look at the struct header. My format for a struct header is you have a certain number of pointers to other structs. So like the struct header knows where the pointers are. I group all the pointers together so that I can crawl like the tree of structs without having to know what's the actual content of the structs, which I may not know at compile time. So this is the offset to the first pointer in a list, and then the number of pointers that live after that. And each pointer is a where is it? It's maybe I can copy it from somewhere else. I forget what my types are named. Here we go, blob pointer. So it looks like that. So I have a nice little function that grabs the blob pointers for me from the blob. So that should be a list of blob pointers. Actually, I don't even worry about the blob pointers yet. Not even worry about the blob pointers yet, because I just want to print out the fields. Let's just worry about printing out the fields right now. So let's see. My instance has a type. So let's see. UTBF struct my type, and then I can grab the reflection data from the instance. Okay, my instance has a type, and I need to index my structs to find that type. So this is where'd it go? That's this guy right here. So then my type is going to have a version. And I need to use a handy lookup function to get that version. This guy right here. Type priv version, okay. And now I can start crawling the, so this version is gonna have a bunch of fields. So k is less than num fields. Now I can start crawling each field and printing stuff. I'm sure I'll need that for now, actually. So let's see. Let's do this for now, just so we have something printing on the screen so I can organize my thoughts here. So when I print this instance, we're just gonna like print the whatever the name of the field is and the description of its type, and we'll worry about the value in a moment. So let's see. Here's the name, and it'll have a value. Wait, sorry, it'll have a type. That'll be another string. Okay. And let's do this too. Printf. Let's print the name of the type. In this case, it will be type. All my types are required to have a namespace. So I need to do this right here. Type name. Okay. Actually, let's start with that. Let's see what that does. So we'll add it to, let's see, we'll print this guy out. btbf print instance, and then hand that instance. So we should see, well, some errors. But once I go in and fix those errors, we should see this is a test2, and so test2 has all of these fields, so we should see all these fields printed out at this point. So where are we going here? What? Variable has incomplete type void? What the hell did I do? Did I make an obvious, silly error? What does this mean? It's on the global namespace. It shouldn't be... Or it's in the global scope. It shouldn't be complaining about this. Yes, yes. Ah. That was probably it. All right. No, that was not it. What on earth does this mean? Why does it think it's a variable? There we go. I just spelled that wrong. Alright, that's fine. Okay, so I have to deal with this const silliness. instance type. I swear I have, oh, it should be priv type. Oh yeah. Okay, so I'm storing all my strings in this p string, which is a, oh, this is easy. I just have to say this p string type. It's like I think the C++ spec. The new one, like in C++ 17, it's called a string view. It's basically the same thing. It's just a flat string in length. Instead of having a zero terminated string, it's just my version of doing that. So I just have to say .data after everything. So that's fine. Some unused variables because I was getting ahead of myself there. Fine. I just want to see if it prints something. Did it? Let's go to the debugger. There we go. Type test namespace 2 test2. So that works. So I made something of test namespace. I made a struct of test namespace 2 test2. I made that struct and then I printed it out. All right. So let's see now if it'll work to print all of the fields in this version. So that'll be BTBF field version field equals version fields. Yeah, like that. And then I can say field dot. What's the name of the field? Field dot field arrow name data. And then for the type, I actually have a function somewhere around here that should convert for me the type enum to, here it is. No, other way around is what I need. This guy converts the type enum to the to a string. So I should be able to use that. And we can print that string. There we go. So all of the types of this struct, I just iterated over all of them. So actually, let's reformat this. So it's a little prettier. Let's make it look more like something we'd actually see in a C program, just for kicks. All right. Do I have to? No, I'm gonna leave it like that. Yeah, it's just prettier. You know, it's not C syntax, but there you go. So now I want to get the actual data from this instance of this struct. So let's see what we can do here. So this is weird because we don't know what type this field could be. There are two ways of doing this, and there's like the you don't know any type way, and there's the you know all the types way. And we're gonna do the you know all the types way later, but we're assuming that we like don't have any information to types just yet, like static information, like compiler known at compile time information. So let's do it. Let's do it like this. We're gonna eventually put the value in this string, and I'll just. But we don't have it yet. So I think we have to. Have I ever actually written this code before? I'm trying to think about if I've written the code before and it's somewhere else in my code, but I'm not sure I have. It gets a value and prints. I don't think I have. And converts it to a string. Let's say I haven't. So I think I'm going to have to switch on the field type. All right. And here are all my types right here. Actually, let me do this ugliness right here. Let's do this case right here as an example. And then we'll improve the code later, because I know that we're going to be able to combine a lot of these into one case. Or maybe not, I don't know. Let's see. So then now we know where the blob is, so we're going to actually need that blob data right there. And there should be an offset into the blob. Wait, actually we should do something that's actually in the struct so we can see the result. What do we have in the struct? An int 32. So E is an int 32. So let's do int 32 first. All right. Now I know I have code that just retrieves the value. In fact, that's what this thing is, VTBF value. So let's see, how do I VTBF value? So VTBF value is a class that that takes an instance and a struct header. We're using this guy now. A struct header. And the type, we know the type. Where's the type? Priv type and a field. We know the field is K. Okay. So I construct this value and then I can use the value to get, I can use this thing to get my actual value out. By just casting it like this. I think that will work. And then I can do sprintf, value string, I forget the arguments for sprintf, string, format, so here we go. That's my string, that's my format, X. Great. And I'll put a default case in there that just, I'm trying to type too fast. Unknown. We just put unknown in there for everything that we don't know yet. All right. Anything we haven't written, you know, code for yet. So does that compile? No. Oh, because I have to say VTBF type : : All right. So that crashed. That's no good. This value that I made, it didn't like it. What is the field invalid? I said uint32. It's just an int32. That's fine. That's why I put that assert in there. Asserts are handy sometimes. Okay, good. So there we go. Negative 100,000 is the value that I put in. Negative 100,000. So great. So good. I'm getting data out of my reflection system. I'm printing it. All right, so far so good. I'm going to clean this up a little bit. I don't think I need a name variable here. That works fine. Cool. So if I duplicate this switch statement like this, then I'm going to have a bunch of, an int32, a uint32, an int8, a uint8. I'm trying to figure out if there's some way I can avoid duplicating all that code. But I don't really want to do templates or anything like that. So I think I'm just going to duplicate the code. It's not the worst thing in the world. I'm going to do it like this. Using the magic of Sublime, my favorite editor. Case VTBF type. All right, colon this thingy. Break. I hate extra white space. And then this part I'll have to do by hand. X equals that same thing. Oops. Actually, you know what? I can eliminate some duplicate code here because this is just the same VTBF value. So I can just call that value right there. Value. All right. Nope. And then sprintf value string. And I'll have to customize that for each one as well. And so now that I have all the basic types, let's see, what were my other types? I have all the basic types, so that should be everything that I need for this particular struct. So I'm going to assert false for anything else. I'll do enums and other structs and arrays in a second. But first, let's update all of these. So this is uint. This is 16. This is uint 16. This is 32. This is uint 32. This is 64. This is uint 64. And this is float, and this is double. You know what? I think I can do this even more clever. There we go. Why don't I just do that in the first place? That gets rid of a lot of stuff. Oops. Let's clean up some of this. All right. And probably Clang will tell me that a bunch of these need to have different percent things, and I'll be appreciative when it tells me that. Let's see. LLD, yeah. And then this one, LLU. Thanks, Clang. Duplicate 32? Oh, yeah. That's fine. So that should do it. This first struct that I'm running this on only has basic types, so that should tell me every basic type. Great. And they all look like they're what I set. My test values were 200, 64,000, negative 3,000, 52 billion or something like that, and then 4 billion. Yeah, it's all correct. Okay. Okay, so far so good. Oh, good. We have plenty of time. So that's all the basic types. So let's see what we can get away with putting this on. This is still just a bunch of basic types, so that should be fine. What is this one? String test. Okay, we can do strings. Where's my string test? Oh, you know what? You know what else I should print? I should print the version. I should print the version of the struct. Version, because I got it right here. Version, arrow, version. Beautiful. Or not. Did I just... Ah, we ran into one that is not... 64. Doesn't like this one for some reason. Oh, test versions. Why didn't it like it? Only basic types in this one. I don't know why it didn't like it. That looks okay. Type is 2, field is 1. Oh yeah, it's the same thing as before. Int 8. Int 8. No, that matches actually. Type is int 8. It doesn't like this for some reason. Let's see what it thinks. The field is 46. It thinks it's B type int 16. B is an int 16, so it's right. Then why did it list it as, why did it try to run int 8 on it? Print, oh, of course. I have a berg. Do I have a berg? Let's see. Just print K. That's all I want. K is 1, which is the second field. So that's fine. The second field should be B. But it's looking at A. Did I do this right? Version fields K. Okay, print version. Print version fields 0 and fields 1 and fields 2. Oh, it rearranged the fields. Is that what it did? No, it doesn't rearrange the fields. Why is... Version 1001. Oh, because, okay, no. Version 1001 has fields in a different order. Okay, that's fine. That's fine. No problem. Oh, because this... I think my VGBF value is assuming the most... is assuming a different version? No, it should assume the version in struct header. Which is 1000, so that's wrong. Ah. Okay, I get it. I shouldn't be using this version. No, I should be using this version. So the instance has a version that it wants to access the data as to do versioning, and like knows what version the data should be. But in this case, we want to ignore that. We want to do. Well, so we have two options. We can use the version in the struct, like the version that the instance wants to access it as, or we can use the version that's actually there in the struct. And just for simplicity, I'm going to use the version that's just present in the struct. So that was that confusion. So that probably will work now. There we go. So there's my test data for the test versions. And so now I think there's a place where I upgrade versions or something. Oh no, it's over here. It's over here. This is a very pared down version of C++. It's mostly C. I'm programming it like it's a C program, but I'm using a few C++ features to keep things simple. So where was I? Here we go. So here we write this object was written with an old version, and then here we go. This is what I want. So we read the old version, and we make sure the data is all the way that we want it to be. And then we upgrade the storage container to the most recent version. So I should get a different result if I put this here as if I put this here. And then we set a field that's new in the new version. And so after I set that, we should get yet another result if I put this print statement here. Except that nothing compiles. Oh, I need this. Well, then you came to the right place if you just started learning, because I'm happy to explain any questions you have. I love explaining things to people. This is probably a little bit too advanced if you just started learning. But you're welcome to follow along, of course. And you're welcome to ask me to explain anything that I'm doing, and I'll try and explain. So good, yeah, it did. The first struct, version 1000, had no D parameter in it, no D field. And then it upgraded to version 1001. It gave it a default value of 0 because version 1001 has the D field while version 1000 doesn't. And then I set it to a value, 1, 2, 3, 4, and there it is. So this print statement is working good. It's working good. Let's see if we can add strings before the bottom of the hour, or the top of the hour. It's the top or the bottom? It's the top. And to add strings, I think the first thing that I want to do is, so I printed out just the base struct that this instance is pointing to. But like here I have another type of struct that points to other structs. Yeah, you can ask about anything you want. Yeah, I'm happy to interrupt this and talk about something else. This is a chat directed stream. So let's see. I'll just keep talking about this until I see another question though. This struct points to other structs, and we don't have a way to like print the struct that this struct points to. We just print the dumb data. So we need to take all of this stuff and factor it out into another function so that we can print structs recursively. So I'm going to do that. I'm going to do that now. I'm going to start by making a lambda. So print struct. And we're going to pass the struct header. And I'm going to surround all of this code that I just wrote with that lambda. And then call it print struct with the struct header. So is there anything else I need inside here? Actually, I should... Clearly, I'm going to need the reflection data. So I should pass that in. So I'm refactoring, but I'm kind of refactoring by not doing anything. with the intent of creating the least amount of damage to the program as I'm refactoring, right? I'm not moving the code anywhere, which ideally means that as I refactor, I'm not changing, like it's easy to, as you refactor, introduce bugs. So by just introducing this as a lambda, and then once I get it working with the lambda, I can move it elsewhere. And that hopefully cuts down on bugs introduced by the refactoring. So let's see. I'm also going to need the blob, aren't I? Do I refer to the blob ever in here? I don't. Bonus. So let's see. Variable priv cannot be implicitly captured by the lambda. Yeah, does the struct not know what its type is? Struct header. It does not. Okay, in my numerical integration videos, you had a baseline analytical integration, but you didn't make a video about closed form differential equation involving solving, which would be great for things like applying per frame drag or modifiers on equations of motion. Closed form differential equation solving, yeah. We can talk about that. That's a big topic. Let's see. So I didn't talk too much about differential equation, like closed form differential equations, because not every differential equation has a closed form solution, and most of the ones that we do, like in video game development, just like there, like as soon as you take like wind resistance or drag into the picture, there actually isn't a closed. I think that's true. I'm pretty sure there's not a closed form solution for that, right? So you're kind of forced to do things with a time step, like one time step at a time, which is actually fine though, because video games are systems, and in a system you don't always know what's going to happen in the future. Like you have a differential equation and you solve it in closed form, and that gets you some curve that goes, infinitely out into the future, however long you want. But then you get smacked by something next frame and it sends you off in a different course, and all that solving you did, like for the closed form solution that, for infinitely in the future, it doesn't matter, because now now you have a completely different solution like every frame, right? So it, like a lot of things you can do in closed form, and then you have one solution, and you can just like evaluate that solution at any particular time. But most of the time you don't. Or the closed form solution is too complicated. That what's a quaternion? Oh, I made like 8 videos on that. So have you seen my videos is the important question. If you have, and you have a specific question about quaternions, then I can talk about that. I don't want to like re-explain quaternions, because I probably did it better in the videos than I could do here, honestly. So hopefully, Programmer Bro, that addresses your question about numerical integration. So I can't. It's down there. It's let's see. Where's my... Cool, you found it. Okay, cool. I'll keep my eye on the chat for more questions. And continue here refactoring stuff. What's going on now? Oh yeah, this guy capturing it implicitly. So I don't want this priv variable to be in this function, because don't do what? Because not every struct is tied directly to the instance, so I have to get this out. So that's fine because I can pass. The type is not here in the struct header, so. Oh yeah, don't go over quaternions, that's what you meant. Yeah, okay, yeah. Not gonna do that. Unless he has a specific question. So I can just pass the type along right here. And then I can skip this. Oh. Wrong window. And then I can pass priv type. So there's still some things that I missed apparently. Redefinition of type. Oh yeah, fine. Fine. Type index. Type index. Type index. Oops. All right. Oh, I guess we do have to pass the instance in, huh? That's fine. UTBF instance, and then we'll pass it in right there. Yeah, because we need a what do we need from the instance? Where was it? We need to be able to pass the instance into the value. Oh yeah, link to your quaternion video as well. I actually think I've not watched that, so I'd like to watch it. So actually, if we print the instance, then we don't need a print. Or I'm sorry, if we pass the instance, then we don't need a pass reflection because that's contained inside the instance. I can just grab it out like this. Where is it? Here. Thank you, sir. I will watch that later. Oh, it's an hour and 17 minutes long. It's in character. If it weren't full of swearing, then, you know. Okay, fair enough. It's just an intro. I'm always looking out for new insights into mathematical truthiness. All right. I need this too. I always forget the semicolon at the end of lambdas. Always. Always. All right. Are we done with the errors? Perfect. So it looks like that worked. Okay. So the last step to factoring all this out is to do this. Static VTBF print struct. All right. Perfect. Void. Sweet. Still works. Perfect. All right. So I'm going to pause it there. I'd like to get farther, but I want to show a completely different way of doing this. So we had, like, we did what I was describing at the beginning of the video. We don't need this anymore. And we looped over all of the fields in the struct. Okay, and then we found that value, and we printed it out, and that was good. And we got these results right here. So cool. But we actually kind of want to avoid this loop if we can, because this reflection system actually generates code, and I'll show you some of the generated code. Okay. The idea being that you take your reflection data, you load it in, you make reflection, and And then you have the library, you have VTB format, print code for you that contains all your reflection data in it. And then it's all known at compile time. So here is the generated code that contains all the reflection data. You can see that like it's just building a list of all of the structs and fields present in this program. So here's the name and the namespace of the first struct. Here's the first field. Here's the second field. Here's the third field, right? And then you compile this into your program, and then you have available to you a list of all structs, all versions, all fields, right there in your program. Even I implemented enums, very basic enums. So that's there too. Related to Programmer Bro's question, in the RK4 video, you said you wrote a blog post about the research I did. I looked for it. Either I suck or you lied. Let me grab it for you real quick. And that's my dog. Copy. Where did that window go? Paste. There you go. Have fun. But I do lie from time to time. You know. It's not one of my better qualities. So what we want to do is print code out that if they compile against that code, then it has all of this information statically. Right? And then like you don't have to iterate a loop at all. So the code will look like this. The code will look something like this. Print test struct. All right. And then you give it a struct, you know, an instance of the struct. And then it's generated code, right? And so it knows exactly what is in it. So it can just printf, you know, like this. Instance, you know, A, right? This is pseudocode, so it's not, but it'll look like that. This is what we really want. And then all of the operations are done at compile time on my computer instead of on my client's computer, on my customer's computer, the person who's running the game, right? They don't have to run this for loop because I ran it on my computer and it just printed out a bunch of print statements, and so that's what we want. So in order to do that, we're going to leave this function behind that we had fun with. And we're going to go over here to the place where it prints out all of this generated code, So basically, this is the interesting part. Like in order to do code generation like this, you have to basically write a little compiler inside of, right? So I wrote a little compiler, just like a compiler front end. It's a parser and like a little lexer and parser, and then a tiny interpreter inside my library, inside VTB format. Honestly, like, I feel like one of the best things I ever did as a programmer is take a compiler construction course on Coursera or whatever, because backward Euler, did I look into backward Euler at all? And if it's not in here, then I didn't. I don't think I did. Yeah, it's not in here. So I didn't. Yeah. Let's look up backward Euler real quick because I forget exactly what it is. Backward Euler. Yeah. Come on. Oh, yeah. How is this even possible, though? Oh, I guess so you have to, yeah, it's an implicit, so you have to solve for it? Or Or do Newton-Raphson iteration. Yeah, I don't think backwards Euler is quite as straightforward as regular Euler. Because of this. Because of this. Which I'm not sure you can do without an algebraic solver at runtime. I could be talking out of my ass. And then, or you can do this, or you can do like a, or you can iterate on it. Yeah. I'd like to see an implementation though. But I think the point of the article was that like regular Euler gives such good results that, yeah, right. You take a step forward and then compute what it takes to go back to the original. Yeah, the regular Euler works so well that I found that it's probably not even worth looking for more involved solutions. But I would be very interested in a solution here. I'm sorry, in an implementation here. Okay, so I have a little compiler front end that parses this string. And anytime it sees a %sign, it looks through it for like instructions. I'm gonna make a note to look into it. Maybe I can do another analysis on it, and that would be interesting. Just open up a tab and leave it there. Yeah. I don't think RK4 is that dumb, honestly. Like, it gives perfectly reasonable solutions. I guess the thing that it really surprised me, because RK4 is for non-physics applications. If you're not integrating position against velocity like you do in the physics applications, it's great. It's so accurate, and it's right in this sweet spot. Like RK5 is don't even bother, right? But when you try and use it for physics applications, it's like, So Verlet is, I think Verlet worked out also really well. And for like, I mean, you know this, for some applications you use Verlet for like simulating particles on a GPU, right? Where you just want to have, you just have a huge ream of particles and the previous positions, and you just do math, and then you update back into the first buffer or whatever. And where was Verlet? Yeah, Verlet is perfectly fine. I mean, like, Verlet and semi-implicit Euler are basically the same thing. I think was one of the conclusions I came to. Yeah, like if you do math for the specific, where'd the chat go? For the specific use case of video games, if you do the math, they're the same thing. So, right. Verlet is super nice for things when you want natural dampening like cloth and springs. Exactly. Yeah, I think I may have mentioned something like that in one of my videos. Yeah, it's just a bunch of math. It's not important. Okay. All right. So let's see. So what I want to do is I want to take this this generated code and augment it so that it prints out all the fields in my struct. So let's see how we can go about doing that. So we have an instance. So let's just add a, it's kind of ugly because everything has to be stored in a string. But what can you do? Void print. Void print. And then somewhere over here, I will say let's see. Instance, print. Actually, you know what? I changed my mind. Print should be a member of the struct, not of the instance, I think. That's probably reasonable. I might change my mind on that. But let me stick it down here in the struct. Where is the okay. So struct name. So right here. Print. I feel like it should be a member of the struct and not of the instance, because you can print any struct individually, but you can't. Yeah, like so. For example, instance arrow print is redundant when I can do like this. And now if I have a struct that contains other structs, then I can do like get child struct, and I can also print that too. So I feel like print should be a member of the struct and not of the instance. So let's put it there. I may change my mind later. And we'll do some test prints. Now if I compile this, I'm gonna get a compile error. I know that for a fact. Here it is. Undefined symbols for my architecture. So it did that because, let's see, what did okay. Where's my generated code? Where is my generated code? Here we go. So I defined the print command. Let's put it here instead. But I didn't define, but I declared it, but I didn't define it. So I updated my generated code. Oh, that's why. I updated my generated code to contain the print statement, but I didn't actually define the print statement. So up here is where I'm going to do that. Right around here. We're going to write this print statement. Where do I feel like doing it? Here's as good a place as any right here. All right. So this is the one file that contains all of the definitions for all of the functions. They probably shouldn't be all in one file like that, but I'll fix that later. So in this file, let's see. And print, I'm gonna put this print function right here, and then close the semicolon, and then that should create an empty print function. So now the compile error will be gone. Compile error gone. And I should have in here a bunch of empty print functions. Good. So now, this is where the compiler comes in handy. Okay. So I have these special commands that my little compiler front end reads. Actually, I'm going to need this. I need this guy right here. That will loop over each field. Okay. So I can do like this. Loop over each field. And like that. And for each field I can print something. I'm just going to print a comment for now so we can see how it works. But now after this goes and have a bunch of errors. Something, 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 something. It worked. There we go. I always forget because it's the compiled, because it's the it's in this string. I always forget to add the new lines. So here we go. Something, 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 something. So it looped over all fields, and then it just printed this comment something every time it was a field. And there were apparently 4 fields, so I got 4 somethings. So let's see. Let's try something a little more sophisticated. we're always going to print the latest version. Yeah, I think that's the best thing to do. Always printing the latest version. I guess I could switch on the version. For now, we'll just print the latest version. We can make it print other versions later. Is that the right thing to do, though? No, it should print the version that's stored in the underlying struct. But damn it, I don't even know what that is. This is complicated. No, this will be fine. I'll start with the latest version. I'll start like this. Or start like this. Via cert. Okay. Struct header equals, and then get the struct header. So I'm gonna get. So I have some helper functions to get the struct header, the beginning of my data from this pointer test struct right here, and then struct header version should equal the latest version. We'll have it print the latest version. Latest version dot version. So I just told my compiler, my little mini compiler, to print whatever the latest version is. So now if we build that, and then look at the code that it generates, and then I forgot to indent it. Okay. Then yeah, we assert that we always have the latest version there. So for now, and then I'll go add the other versions later. So then for each field, we're going to loop over the fields, and then we're going to print the field index. Instead of something, we'll print the field index just so we know what's going on. Okay. Looping, printing field index. There it is, 0, 1, 2, 3. Well, that's pretty boring. It's about what we want, though. Okay. So what else do we need here? So we want it to say something like, oh man, I don't have a switch statement in my front end here. It would be really useful. Otherwise, I'll have to do a chain of ifs. So what I need to do now is I need to switch on the type and use a different print statement depending on what the type is. But I don't have a switch statement in my front end compiler, and it wouldn't be too hard to add. But yeah. C's, okay, 0, 1, 2, 3, 4, that's fine. It wouldn't be too hard to add, but I don't think I want to add it tonight. Okay. Let's just do this. If, so let's see, field index. So I have to look up the type of the field that we're going to print out. So I think I can just say, field index. Yeah, I need this guy. Okay. So there we go. Uh-oh. It crashed. Oh, it's because I have this if right here. Let's take that out for now. Oh, it crashed again. Because this is not defined. My error reporting in my little front-end compiler is really bad. So here we go. So here are the offsets. So I have existing code for getting the value of, actually I don't even need to do that. Yeah, I can just, let's see. Because I know the names here. Let's see if I have dot offset. I have dot name. I wonder if I can just say dot name like this. And then that errors, but did it not update? Oh, damn. That's not good. I should modify the code that I'm not modifying and not other code. All right, here we go. A, B, C, D. So I should then be able to say, because I have accessors for every like value. So I have like E, F, G, H. I have accessors for everything. So I should be able to just say printf, you know. Oh, that's not good. Uh-oh. So my compiler takes this this guy right here as the special character that, oh, I didn't even think about this. I mean, I thought about it as I was writing the compiler, but then I thought I'll probably never need to do any printfs in my generated code. I wasn't thinking to do a print function when I did that. What's the command? Oh, that works. Cool. Could not load any Objective-C class information. That's a riot. Yeah, like, my compiler will see this thing and think that it's a control character for wrapping one of the instructions that I pass to it, and that's not good. That's bad. I can't decide what to do about that. Hello, Cuber Caleb. Well, I hope you were well informed. Okay, I know a super hack that will let me work around this. C hex string literal. Maybe I can find like the hex value, yeah, like escape sequence for the %, and then load that into the string instead of the %, so I don't have to, yeah. This will probably work. The byte whose numerical value is given by this hex. Okay. Good, and let's look up ASCII table. Perfect. I've been here before. Where's %? Why is this ASCII table an image? % is hex 25. So let's try this. X25D. That's super gross, but it just might work. Yeah. We'll see. We'll see if that works. Hex escape sequence out of range. How can that be possible? It's 25. That's in like every range.
Not even integers.
It's totally an integer. Oh, I know what to do. Ha! Wait, that still won't work. No, I need to do it that way. It's 25. Oh, because it thinks it's x25d. Oh, what am I gonna do about that? I don't think this will work, and it's super ugly, but it's worth a shot. So split it up into 2 strings and put the hex character in one, and the D in the other. It does appear to have worked. For now. What are the errors, though? Unknown type. Oh. I don't know where that came from. Okay. Okay. So now it's telling me undeclared identifier. Bunch of undeclared identifiers, but that doesn't. I'm not sure I believe it, because here we go. Undeclared identifier B, but B. So test namespace basic array 1. There's A, and there's C, and where's B? Yeah, well, it's right. There's no B. Oh yeah, because B is a string, so it doesn't have the same accessor. That's fine. We can gate this using the same things I did over here. Is type. Oh. Well. That's fine. We're going to need to do different things for all these different types anyway. So like if it's a struct, we're going to need to do one thing. All right. If it's a string, we're going to need to print it a different way. If it's an enum, we're going to need to print it a third way. If it's an array, you can see I haven't implemented all of these yet. And then otherwise, it's a basic type, and that's what we're interested in right now. So here's a basic type. So I'm going to move that guy down here. So for the basic type, we're just going to oh, good. This is progress. This is progress. So it's not. Oh my god, this is so ugly. Look at that. So ugly. It's fine though, because it's generated code, and I don't want to like rewrite the compiler just so I can output a, you know, that percent sign. So this will do fine for now. So, but we still have like this problem of floats want to be printed with %f, and integers want to be printed with %d, and 64-bit integers want to be printed with LLU and LLD. So, have to decide what I'm going to do about that. More if statements, basically. If field.type is, yeah, glad you like it. It's either that or rewrite my front end so that I can emit a percent sign. I should do it. I will do it. I will do it eventually. I just don't want to do it here on this stream. So, I'm not a bad programmer. So what I want to say right here is, if field.type is if what am I doing? If it's a float, then I do one thing, you know, and if it's not a float, then I do another. But I don't know if I've implemented that in my little front end. So I just need to write an F right here. Yeah. I'm probably never going to use the @ sign. And you know what? If I do that, it'll stop giving me the stupid syntax stuff like, hey, you know, it's coloring it red because, hey, you forgot to put the thing there. Okay, let's dig into the lexer. Let's do this. So where's my lexer? All right. I think that's a good idea and I like it. So I think that's the only thing I need to change there. And no, I need to change that one too, probably. Yeah, so this is where you start echoing. Yeah. If I can avoid a shitty hack by doing this right here, then I'd like to do that. So here we turn echoing, let's see, if we're echoing, we turn echoing off when we hit one, we turn echoing on when we hit one. So that should be fine. So my lecture's updated. I think everything else with the compiler should be fine. And now I just have to, oh my goodness. Help me, Sublime. This will work. This will be fine. I'm not scared at all. You're right, it's a good character. It was kind of short-sighted. It occurred to me when I was writing, I was like, I'm probably not gonna have to write some print statements, and then I could just work around it somehow. I just write an escape character. But, you know, the @ symbol is better than that. Oh my god. I don't want to, like, hold down Control D too long and then run off out into the, whatever comes after this. It's probably just another template, but... Oh my god, oh my god, oh my god, oh my god. There's so much. I'm honestly surprised that Sublime hasn't started slowing down at this point. It's got some kind of internal list of all of this stuff. My coworkers are like, you know, cursing Visual Studio every time it slows down. And I'm just laughing because I use Sublime and it absolutely never freezes up. But I still have to debug with Visual Studio, so... Okay, here we go. This is probably fine. Yeah, good. So if I missed even one, I'm gonna get the weirdest that. Oops. And it can be tough to figure out what they mean because I don't have any error reporting in it, which is because I'm a bad programmer. Let's see, the symbol name is, oh, no, it's because of the thing I did. So that's a good sign. Equals float. So this guy right here. We'll just comment this out for the time being so if we can see if the @ sign thing worked. Excuse me. You're saying 2010 doesn't crash on you? Because, like, yeah. Well, they force us to use 2013 at work, so I don't have a choice. I think I used 2010 a lot and it wasn't so bad. And the worst part about 2013 is there's this little down arrow that appears up like every time you try and hover something, and it's for refactoring, which I absolutely never want to do, but it gets in the way of the hover thing when you're trying to inspect variables. And like I'm trying to hover a variable to inspect it, and it's like, you want to refactor? No, never. Go away. So that appears to have worked. So now I just need to figure out if what my type is, and I forget how to do that in my system. So let's see if I do it anywhere else. If is type struct, If is type string, well, that answers that question. It looks like I'm gonna have to write another function, which is fine. Oh, maybe I can get type keyword. This might work. Yeah. Well, that just means that in 10 years you're going to be like Sean Barrett and still using Visual Studio 6. You're going to be the holdout with 2010. Let's try this. I don't think it will work because I don't think I implemented string literals. Yeah, why is my code string literals? So we got a latecomer here. So this is a okay. How do I explain it? Yeah, my lecture isn't like that. So I'm programming a reflection system, and it's doing code generation. It's generating this code. Well, it's not generating that code. I'll show you. Hold on a second. It's generating this code, right? So you can see, what are we working on right now? The print statement, and so this print statement corresponds to that print statement. So it's a huge string that contains all of the stuff that we're gonna print out into the generated code, and that's why it's all in a string like that. Yeah. And these little @ signs are the control signals that tell my little precompiler what to do basically. So your plan is to switch to 4-coder once there's a good Linux debugger and drop Windows completely. You see how I'm using LLDB, man. Like, it took a little bit of adjusting, but it's not terrible. Actually, and GDB, I can't show it here. I don't think I have GDB installed. GDB. No, I don't. But LLVM has this, which I'm not even sure how to use. Undo. Why did I do that? Let me actually run the thing first. Let me run something that crashes. Nope, that doesn't. Okay, hold on. I haven't actually had an opportunity to. Well, LLDB is terrible. You're right. It's very terrible. But I don't know. I got used to it, and I don't feel like it's that bad anymore. And there's this thing which I've been meaning to try. It looks like it does its thing. I haven't used it, but it might be. My other option is to cave in and use Xcode for debugging. Which, I don't know. Could work. Actually, I should probably do that because it's probably really difficult for you guys to follow what I'm doing in the command line debugger. So I should probably figure out a different debugger if I'm going to keep doing this stream. GDB has more features than Visual Studio, but Visual Studio has every single feature instantly available. It's true. It's true. I mean, we all know this. Visual Studio is terrible, but it's the least bad thing. So, going through all the CPP con talks, and I found where is it? There are so many. This one. This one? So GDB has the same kind of thing, like a UI mode when you're debugging. It might be worth trying. I don't know. I've never used it, but it's supposed to be pretty full featured. And then you can use like the reverse debugging stuff that GDB can do. That Visual Studio, I don't know. At its rate, it will practically never get reverse debugging. What's the rationale for code generation with string interpolation instead of macros or templates? Macros or templates? So, so you're saying like, okay, yeah. So, yeah, so some reflection systems use macro soup basically, and they do, let me close this. They do like, I don't know. I know some engines that do it, but I won't bother bringing them up. I think we're talking about the same thing. And they like, I don't know, it's messy. It's macro soup, right? There's no generated code. It's doable. I've written reflection systems like that before. I'm doing code generation this time just because like I don't know. I honestly don't know. I thought it would be cool. Wait, I do know. So you can do this. You know, I don't know. Am I even answering your question? I feel like you do code generation and then you can get like really specific stuff like this. An interface, you know, this is my struct. These are all the fields of the struct. I have getters and setters for it. I can do callbacks, you know, like if I don't know, it's all really neat. And like you do macro soup and you don't really get this. You can't write against something that looks like it was part of the language in the first place, right? It's kind of uglier. So I decided to try this. I've done it both ways, and at work we use a completely different reflection system that's basically template soup, which made me mad, and that's why I wanted to try this way. But yeah, that's the other thing. Person with the yellow name that I can't read. It's easier to step through this sort of thing. Although if you actually look at the code, like drawback of doing it this way is that the way I've done it, all of the data is in it's just a bunch of bytes, so you can't actually inspect individual fields unless you do something like get out of this thing. I don't even know. Oh, that worked fine. Great. So I can do print this, like this print statement we just wrote before. I can just call it on the command line, so that's helpful. So I kind of don't have to be able to see the actual memory. You know, I don't have to be able to say print instance and then see all of the things inside of it. Because I can just print this as kind of wordy, but you know, I can make a shorter version or something. I don't know. So that's a drawback of doing it this way. Visual Studio has the same thing though. You can there's the immediate window in Visual Studio. You can type a command like this. I think you can type exactly this in here, and it'll do the same thing. So I don't feel like it's terribly less efficient to do it this way. Your time wise, not processor wise. Anyway, so let's see. Let's add a function here. This is my huge table of functions that the template compiler knows about, and we're just going to add is type float. Is float. That's pretty simple. And then we head back here. We can say else if is type float. It's not the prettiest way of doing this. But I'm trying not to add too much complexity to the compiler. So let's see. That should deal with the float case. Let's see if that works. It does appear to have worked. Yeah, there you go. So good. Now let's do it again for double. Is type double. And we're going to do one for is type uint64, which is, it wants to be LLU. Oh, wait. We did all of that stuff that Sean suggested so that I could use this guy. And I forgot to actually do him. There we go. That's so much nicer. Got rid of an ugly hack. Alright, so type uint64, and then type int64, which would be LLD, I think? LLD. I basically, ever since I started using Clang, I never memorize these things anymore, because Clang just tells you them. It's amazing. Okay, good. So now it doesn't recognize my functions, so I'll do this. This is not the most amazing code I've ever written, but here's double. Double. Here's uint64. Uint64. Here's int64 and int64. And it still doesn't like that. What did I do? Really? Oh, I know what I did. I'm missing a curly brace here somewhere. Am I? Am I missing a curly brace? It's looking for an open curly and couldn't find one. I think that means I'm missing a... Let's see where it's looking. Oh, okay. My lexer is wrong. All right, back to the lexer. So the part of the lexer that lexes function names is wrong. My function names don't accept numbers in them. I didn't bother doing that. So let's see. Identifier. So I'm actually going to need two functions here because an identifier can't start with a number, but it can start with anything else. So we have two functions, identifier start and then identifier. And then identifiers, identifier start, or p is greater than or equal to 0 or less than or equal to 9. All right. And now I can say here, if it's the start of an identifier, then just suck up all the identifier tokens that you can find, and I think that should fix it. Okay, good. We've made some progress. Error, type specifies format int, but has argument type of double. Oh yeah. Double is %f, not %d. Fine, fine. Good. Where was I? Oh, here we go. So here's my print function that it's easy. There's no for loop. It just prints everything. It knows it at compile time. Everything's hunky-dory. Let's see if it actually works. So I'm going to come in here. I already have print statements that I can work with. So Let's just run v2b format 2. There they are. Perfect. The data looks good too. So now we got the actual data printing, which is what we wanted. So now let's print like the other trappings that we did before. What did it look like? This junk. This junk. And we can just write bare printf statements for that because we know exactly what it's going to be. Struct, and then basically this. Okay, version, and then the latest version dot version. So we print that. And then at the end, we print an ending curly brace. And in the middle, what was the format? We print a tab, and then the name, and then the type. So let's see here. For each field, we print a tab, and then the name. And the name, and then these, and then the type. Type. So to print the type, I actually need what type should I print? I have a special function that prints the type. So not this one. Oh, you know what? It's going to be down here somewhere. Get type keyword. That's what I want. Get type keyword. The name and then the type. Get type keyword for field.type. Why don't I just say field.name? Why am I bothering with this type index stuff? Should work fine, because I assign field right here. That's the other problem with like working in the generated code like this. Is it's really easy to like you can't really see your code. I almost wish I hadn't made the compiler front end, because then it would be that, you know, if I had just done it the regular way, it would have been like, you know, for, you know, num fields. And then I have all my syntax highlighting and everything, and with this I don't. But now that I have all this stuff, I may as well just keep using it, I suppose. I don't know. I may get sick of it and tear it out. We'll see. Okay, so I screwed something up. Oops. Oh, it's trying to print a struct. All right, let's do this. Printf. So my function that prints the type, like it accepts the type and it prints it out in a string. It never wants to print the like a struct, because a struct always has an actual name. And so I just assert right here, instead of printing something stupid, I just assert. So I'm like, don't do that. You should print the actual name of the struct. So I'm just going to move this print statement in here. And actually, why don't I just do this? Yeah. Load it right in there. Okay. No, I shouldn't do that. I should format it. I should use a formatter. Just to be consistent. And now what? Equals, and then it'll print the value, and I'll have another print statement at the end that prints just a semicolon and a new line. That should do it. No crashes. I screwed up somewhere. Oh, so I need that. That'll probably fix it. Nope. Why does it think? Oh yeah. Oh yeah. This is silly. I need to do like this. There. Whoa. Oh. That was sublime. Perfect. And when I run it, there it is. Okay, well, my new lines are off. But, oh yeah, because I have new lines in here everywhere. I don't need them anymore. And where do I not have a new line where I need one? Right here. Right here. Did I do it? Oh, right. Sometime. Here we go. Perfect. No, not perfect. All right. This is where I need to add it. Oh yeah, that last one was in the wrong place. All right. There we go. And the generated code looks not quite as pretty as it could, but I think I can clean this up a little bit because I'm doing a printf every line, and I can use the compiler to fix some of that. But it's a lot better anyway. I like my generated code to be pretty, you know what I'm saying. So instead of doing a printf and then all these if statements, I'm actually gonna this will probably be cheating. I don't think I need this anymore. This will probably be cheating, but I'm gonna interleave this printf with all of these if statements. So I'm just gonna print field name and then end of string, and then the if statements go, and then I can take off the, this guy right here, because it will continue from the previous string. So let's see if that doesn't blow everything up. It does. That actually looks okay to me. Oh, Why is it doing that? Oh, because it's hitting other ones. Okay. So I need the, I need it to just close it right here. And not anywhere in here. So it'll close the string, this guy, and then all of these guys will be empty, I think. Yeah, because I can do like this. I can put that there. Delete these. No, I can't do that because these guys don't have accessors all the time. It's fine, I'll do it this way. Gonna insert simple closing ones for the types that I haven't implemented yet. Okay, okay. I think everybody is probably completely lost at this point, but don't worry, I'm gonna get there real quick. Then I'm just gonna take this and load it directly into here. I was doing that before and I decided not to, and now I'm doing it again, so whatever. So that's an improvement. A colon type equals, and then take this stuff out and take that out. Now what does it look like? Okay, that looks a lot better. For the first one anyway, and then it goes haywire. So A colon type, so name colon type equals %D, and then gets the name. So then I don't even need this. So I can put it here. So that'll clean it up a little bit. No, except it won't because these guys need to go here. Oh, that's not what I wanted. All right. Getting closer. Just need to do the closing quotation mark. Perfect. Perfect. So now when I run it, well, I forgot to output new lines. That's fine. New line. New line. Better. Much better. And semicolon. All right. That looks a lot nicer. So let's see what's here. Let's see what kind of things it's outputted. So let's start at the top. Just a series of print statements now. So when I do instance get struct print, then it's going to call the generated code version. It's just going to print everything. Oh, it's not. There. It's already outputted a bunch of if statements. It just calls all these if statements one at a time. Which is nice. In the case of like printing, you're probably more bound by the printing is slow than you are bound by the cost of this for loop that we wrote before. Where was it? But you know, you can use this idea for everything. Like, it doesn't have to be print statements. You can do whatever. You can do, like, if you want to clear your struct and set it all to defaults, then instead of looping through everything and looking up what the default is in the reflection or whatever, and then setting it and whatever, like, you can just write a function that does each thing. And there's no extra processing from templates because, like, it's all done it's all done in like in a previous step. So saw a CPPCon talk where he did basically the same thing but with template metaprogramming, and oof, it was unrecognizable. Very clever but unrecognizable code. Like, it didn't turn out anywhere this pretty, just printing a bunch of statements to the, you know, to whatever. So cool. So it's 8 o'clock, officially the end of my stream. I'm glad I got all this print statement stuff done. Actually, before, I think probably Handmade Hero is starting around now. Let me see. Nope, they're offline. So maybe I'll go on for a little more. Until I get bored, basically. But there was something I wanted to do before I go. What was it? Oh yeah. Before I put this down, I'm gonna put this print statement in a bunch of other places and see, yeah, like, I'll take this one out now. This one has served its purpose. And instead, let's do instance get struct print. So we're gonna use the new code generated version of this function to do the same printing as before. Oops, let's not print the old version because we haven't added support for that yet, which is fine. So there it is. So it prints out the same stuff as before. Let's keep going. Let's add it to more stuff. Add it here. But we're not getting strings. We're not getting anything interesting. Let's see, instance. Oh, so we in this test we just read a string instance and then we print it. So we can print it a few times because I change it during the course of the test. No, there's no point. There's no point in printing it multiple times because I'm not printing strings yet. So here we go. Add it to pointer test. We're also not recursing through structs. So our print statement needs a little bit of work still before it's complete. That's fine. Oh, I have not done enums yet either. I'm not brave enough to put it there. So let's see. Let's run it now. Oh yeah, we get a bunch of stuff. So anywhere that I... oh wait. All the semicolons are wrong. Oh my god. Did I really do that? I put the semicolon on the wrong side of the new line. There we go. That's better. Yeah, anywhere where there's information that's not a basic data type, it just is... Let's see, we can probably fix that. We can fix that by putting new lines here. There. So it's not sophisticated enough yet to print the string B. But we can probably do that pretty easily, actually. Let's see. Let's see. So we know this is a string, so we can just type string equals and then load in, let's see, %s. Just load %s because we know it's going to be a string there. Okay. And then yeah, and this, and then this, and then give it the field name. I think it's true that the accessor, let's find here, the accessor for strings returns a const char, so should we find string test? And no, it returns a VTBF string. What is that? I forget what that is. VTBF string, which probably, oh yeah, so I just have to call .c string on it. Okay, that's easy. .c string. You've heard about me, huh? Good things, I hope. And that should do it. Maybe not. I'll have to see what it puts out. Yep, that's definitely wrong. I forgot. This should be a double escape. We are programming a reflection system, which can be used for getting data from your... Yep, that was me. Those were both me. Thank you. Can be used to get data from your program, like at runtime. I explained it at the beginning. It's going on YouTube, so you can watch that to get caught up to speed. But I'll do the quick version. Here in my, like, I have this data definition file, and it contains, like, here, string test2 contains a bunch of data, some ints, some strings, and that sort of thing. And then I have some template code that outputs like functions that can operate on this data. And so, for example, string test 1, where's string test 1? String test 2 is what we were just looking at, and string test 2 prints, where's string test 2? String test 2 prints out all of the data from the struct, and that happens from this generated code. It prints it all out. And you can see the result over here. There it is, right? So this printing function right here, which was generated by my reflection library, printed out all the data that we loaded into the string test2 object. It's a reflection system, so it's kind of like, you know, higher order thinking, it can be confusing at first. I'm happy to answer any questions, like ask me anything. I love explaining stuff, as you can tell by my Math for Game Developers series. So that was really easy, actually. I feel like maybe continuing with that, but I'm gonna go to the bathroom real quick. I'll be right back. All right. Dot product video is one of my favorite videos, to be honest. Yeah. Because of the whole backstabbing thing. It's just like one of the most... So many of my videos were about like how to make things move. And after the 20th how to make things move video, the dot product video is kind of fresh air. Let's see your math library. Handmade math. Ooh, somebody watches Casey. Oh, wow, yeah. Trying to find the actual header file. Oh, of course, it's right here. So, okay. Oh. Oh, cool. So you have a union. Hold on, let me make sure I can still read the chat. You have like a union of all your vector types. So you have like HMM-vec2, and that's interesting because you have a union XY and a union UV and a union left-right. That's interesting. I wonder if you're gonna have, if you do it that way, maybe I should bring it up on this screen so we can all see it. If you don't mind me talking about your math library. Where was it? Let's see. Yeah, so like I try and stay away from unions for the reason that like compilers don't like them. So if you try and do it's very specific, I know. So if you try and do like struct vec2, okay, and how did you do it? Oh, you just okay, we'll do it this way. Type def union vec2, and then one of them is a struct, and one of them's like this. I think like Valve has basically moved all of their math code to oh, thank you, to SSE, even like the gameplay programming math code. I think I heard that in some talk or something somewhere in the source engine they've done, but yeah. I don't really see a big case for doing. If it's just like a small engine for your home project, SSE is good. For, yeah, like Sean says, for lighting stuff, but it's kind of overkill. So if you make one of these things, vec2, okay, and you want to have any default parameters like this, you know, I usually so like a vector class with default parameters. Vector class is really low level, so you might want to argue that vector class shouldn't have any default parameters. But I kind of like to put them there anyway, because you can always do like this, right? You can always just take some huge mess of floats and cast it to a vec3 or something, and then you have uninitialized memory, so you don't have to waste, if you're really that like gung-ho about not initializing the memory. But you're gonna get way fewer bugs if you just put these equals 0 right here. But the union won't let you do this. Like, the compiler is really picky about what you do with a union, and because like if you put this one equals 0 and this one equals 1, then these two refer to the same memory, so it can't equals both of them. So so it doesn't let you do it. Yeah, but then some, I mean, you got to think about what other programmers do with your code too, right? Like, some other programmers just going to do this. They're not going to write the initializer. And then uninitialized memory bug. I mean, to each their own. You can, like, let me show you what I did over here. You probably, if you use unions for everything, you're probably going to choke when you see this. Where is it? So this is a node on my AST. For those who don't know what an AST is, it's like when a compiler parses a program, it builds a tree of everything in the program, and each node represents like one if statement or something like that. So anyway, all of these structs could have been unioned, because like you can't be an echo and a block at the same time. But I just like every single node in my tree, it wastes so much memory. There's so much memory wasted. But now I can have the, you know, the initializers, and Sean is probably coughing now, or choking now. So anyway, let's keep looking at this thing. What are you guys talking about? The inverse square? Yeah, I thought, yeah, this thing right here. Oh. Oh, you guys have already talked about this. Okay, yeah. You can mem set to 0, that's true. Could you initialize the members of a union in a constructor? You could. Yeah, that's completely fine. Yeah, that's legit. I didn't want it. I don't have a constructor on this thing, and I didn't want to bother with one, so I didn't do it that way. Well, but then like, so in my case, I have a bunch of different stuff, and if they were unions, then like the memory of this thing would overlap with the memory of that thing, and so like I would have to have a huge switch case inside of my constructor, and sure, you can have a constructor with, so he just means like, you know, I have a constructor here. You don't use constructors, yeah, and it takes the node type right here, and then I just need a, like, have a switch, right? And because if all of these were unioned, then I wouldn't be able to have these default assignments, because all the memory would stomp on each other. Compiler will actually complain. But if they're union, then I could just have a switch here and only initialize the one part of, like, now it's a discriminated union, right? So you can only initialize the one that needs to be initialized. So that's legit. I didn't want to bother with that, so I didn't. I'm okay with wasting the memory, with having a huge waste of memory, and then I don't have to bother with all the caveats of unions. Like it's like who cares? You have so much memory in the computer. Who cares if you waste a little bit? Just, you know, in the case of this library, where was the vec2 definition? Yeah, you don't want to union this because you just want to have like different names for it, but I don't know. I mean, you do want to union this because you want to have different names for it, but I wouldn't. You get the idea. Oh no, you can't do that. You can't do that, Sean. I agree. Okay. Let's add where was I? You metaprogram exactly that's why everything you do is a union, because you generate the switches on type with metaprogramming systems. So you get discriminant. Yeah. No, that's legit. So you mean like your unions are generated code, and so you can generate all the accessors so that you can access it safely without grabbing the wrong memory? I think that's what you mean. Sean McGrath style metaprogramming is going to be a completely different animal than modern C++ metaprogramming. So be careful what you ask for. Like, I don't think you'd have, like, this style metaprogramming. What I'm doing here is completely unlike. Let me show you the equivalent in the CPP-Con talk. This guy. Not that one. I haven't seen that one yet. Yeah. Here we go. So this does the exact same thing that that I do, that I just did, except it does it with template metaprogramming, and it's incomprehensible. Yeah, and then auto generate dispatch function. So when you write the body of the function, you get 100% type safe non-inherited type with just overlap memory with the parent type. Sounds pretty cool, actually. I'd like to take a look at that if you don't mind. Right. Template metaprogramming is the cool metaprogramming, depending on who you ask. I have seen your stream a few times. I don't generally watch streams live. I'm usually like checking them out on YouTube. But I have seen a few things you've done. Sweet. Maybe I'll drop in. So then, like, your accessors have got to be. So you might have a, like, you have that big mess of that big, like, union mess that you just said. And then you have like a my entity type, you know, like something like this. Get a, and then you, I don't know. It's got to be type safe, right? So my entity type, something like that, I guess. Yeah, cool. Then I'll get it from you tomorrow or something. All right. Everybody over to Sean's channel? I'd be down with that. I have 2 computers here, so I can, let's see. I can pull up your stream from here. We can cross the streams or something. You're saying do this? Yo, I got the cheap internet connection. I don't know if it can handle this. We'll see. If I start lagging, it might but we'll give it a try. And the lag will be crazy. Waiting on Sean. Okay, I'm going to do a little more coding while we're waiting on Sean here. And then Sean will completely take over my stream. It'll be great. No, I'm going to stream his stream through my stream, so you can just keep watching my stream and he'll take over. Okay, let's see. That's you. Okay, I guess it's got to take a second to buffer or something. I think you need to work on this. Your markdown here. Come on. I want to see them MOBA devs. MOBA devs. the markdown. Here we go. All right. Press and play. Play pressing. Oh, I see. Let's try again. Yeah. I saw a little mouse moving there just a moment ago. Hello, hello. One more time. I have my speakers muted. Actually, I'll just put headphones on. That is a good point. Oh, I can hear you. I think I can hear. I can hear your keyboard. Why is this damn overlay here? Yeah, dang Twitch. Okay, well, this will have to do. Where's the remove overlay button? I can hear myself through your channel, I think. Shouldn't have opened that. I don't get how to do this. Actually, that was handy. I'm gonna leave it like that. Alright, well, I'm not getting rid of this arrow, but let's watch Sean. Okay. Right click, inspect. It's a Mac, bro. There's no right click. Oh. Just control click, I guess. It's a good idea. How do I... Huh? Hey! Twitch chat is smart. Alright. We'll hang out here and wait for Sean to come back.
More food?
No, I'm good, thanks. He couldn't have left the video showing any code worth reading, I guess. We can hear you.
So what I do is I have a type entity, and I specify this is basically in O of this would be. Then there is create these dispatch functions, which this would essentially be the equivalent of so this is a dispatch function. Inside of call this entity tick player entity. That's this macro here that got generated by the metaprogramming system. It takes player entity, right? So you can see what its signature is. It takes an exact player entity type. It doesn't take the parent type that it's subclassing or casting. No casting, no nothing. It's completely type safe. It actually takes a player entity, right? You can see it's called E. So Visual Studio shows all of the things there. And they also include all of the parent stuff too, because the parent is actually pasted directly into the main type. So I think what you mean by global again is, so let's look at player entity, right? Yeah, you just ready to do dispatch. But like if you think about it, like how many are there? Tick, init, kill. You want to render? Yeah, you add a render. I don't separate my render and my like tick function, so that's not an issue. But like even if you did, right, it's gonna be like render, tick, init, kill, something like that, right? So you're looking at collide. You're looking at like 4 or 5 anyways. So it's not a and you can have a default, like it the system allows you to have a default function that just, if you don't specify, if you don't want to specify it for a specific type, you can just call something the default one. So like this dispatch thing, you can call the default one anything. The default one. So whenever dispatch tick gets called, so whenever you can call normal, you can call tick, it automatically calls the parent's update function, which is the default one. It's going to be the equivalent of calling the parent one, which is the version code. And then after that, it will call the main one. And it handles the cast here. But this isn't like a dangerous, this is not a generated system. And it's also not a dangerous cast anyway, because this type here has the entirety of the base type. All of this is the base type. It has this in it with overlapping. So if you copy that, paste it here. It has the entirety. This will line up. Fuck, don't do that. Anyway, again, sure, coming up, it's not sublime. But, yeah, it lines up perfectly, right? So all of these subtypes start with the exact same data that's here. So if you have a base type, if you get just a pointer to some unknown amount, you can switch manually on the type if you want to, but all of the stuff that will be in the base type is the exact same as all of these. So you get effectively inheritance without any of the nasty stuff of actual inheritance. All of these functions you would write automatically. So I use it for everything that I've ever used. Whenever you want to dispatch on type, instead of doing it with like the sequence, I do it with this. And I might switch this later to use an array of contributors. I'm not sure yet. But right now, just doing a switch. I don't know if this one's actually probably. And then other nice things that you can do is you want defaults, right? So you were talking about default parameters. So I add defaults somehow. Yes. So the reset entity. I don't remember how the defaults work. They work, but I've used them. Maybe they don't actually work. Maybe it just generates a separate. Oh, right. Okay. So I generate this. All of the params, anything that's listed with param in the meta system. I generate an S expression file that I can then go and edit and change these default
Ooh.
without having to recompile. So it's pretty nice. And I don't think the code was that like so like one kind of nice thing is it's right? It's fast, right? So I can just come down here. But like I can just erase all this, right? So this is that's the meta system, and I run the compiler. But it will regenerate this instantly. Like it's not slow at all, and it just runs. Cogent W's, which yeah, like the actual cogent thing is only 1,300 lines, 1,250 lines, so it's actually quite small, and it handles. I don't know if it's really handy. It's just like a string.
So you just print Fs.
I just print F what I need. It's not. I don't do anything super fancy.
Yeah, I think my
Things fancy
code was too fancy.
is because I find they're really hard to understand. Like I'm not going to be able to look at this code here and understand it. And if I make it fancy, I really won't be able to understand it. But it's like 1,300 lines and you can write it in a day or two. So it's just like, fuck it, if I need to change, I'll just rewrite it. And it won't take very long at all. If I need like little functions, like, yeah, I just do the JavaScript. Like if I'm like, oh, common func after, common func before,
Yeah.
I can probably guess what I need to do to add, if I want to add like a new thing that generates code. It's here is very important just because you can figure that out what it is.
But writing compilers is so fun.
I'm functionally fucking fan. Don't know what it is. Okay. It does the fucking thing. Like there's some
I'm sure it was an important fucking thing.
it's not easy to understand. Writing compiler code is fun. Reading compiler code.
That's true. That's true.
Yeah, like I mean, it's kind of. I can figure it out.
Do you do versioning?
It'll take me 10 minutes to parse just what that is.
Yeah. The hell is this?
Oh, this is the S expression parser. So I guess if I wrote the code
Just for doing.
the S expressions too. One nice thing is I have, no, I don't care about that.
Okay.
I found that to be useful. Only for save games. And then,
Original motivation for doing the reflection was things like saved games and file formats.
one nice thing that I have is I have a tokenizer.
Same problem.
Header thing, and it shortens
So
So I have a tokenizer that I can reuse, right? It tokenizes C,
versioning.
most C-ish, like obvious like programming type languages.
Yeah.
Has a little bit more than C too, but like it tokenizes.
Hmm.
Just tokenizes things, so I can very quickly write stuff like this. I don't have like a generic parser because that's. I don't actually understand how to write a generic parser. I guess that's why there's parser generators, but it parses and generates. Like I could write a parser specifically for something, but
Generic
type parser I don't.
parser isn't worth writing IMO.
Yeah, if you're doing like this system isn't. It doesn't have a lot of overlap with what you're doing.
Yeah.
Mine is specifically for in-game fights. So
Yeah.
I don't want to have to use a data structure if I don't think it's a good idea to use a data structure.
Yeah.
So I like arrays. And one of the nice things is if you keep if all of your entities are roughly the same size, then you can, if they're a union, and you just keep them in an array, then
Yeah.
you have an array of entities, and then you never have to worry about anything, right? So that's my big motivation for this, is I want everything to be an array, and I want everything to be super type safe, because I hate type errors, and I'm not using
Type safety is the best.
So I want something that's type safe, generic code, and fixed size memory, and this seems like the best way of doing it. I also have like a little bit of, like, I have stuff like, oh, you have a file, look up. So this will like read a file and it'll be like, what name, where do you want to start? Like, what's the start point, macro, and then end point macro.
Right.
So if you look at here, I use meta inline begin. So this function here will just return to you where the start point and end point and where you want to inject are, and then how long the code is before how long the code is after.
And your
And when you want to write,
injection is just right over the old stuff.
before stuff, print the shit you want to print, and then print the after stuff, right? It's super simple.
Yeah.
And this is another big one here, actually. This is a huge function that's really useful. It's generated named enum. So basically, I've used this recently. Oh, right, okay. So in the animation editor, yes. So in the animation editor, I metaprogram the animation system. So character animations. So we only have one character. So I use this generate named enum thing,
Mhm.
and it just generates named enum.
Yeah.
So it generates the enums, and then it generates an array of strings, wait for the enums, and that's it. So I don't have to do this manually, and I have the names of all enums, right? It's like the most obvious feature.
Enum metadata for every enum.
The ability to give names.
Hell yeah.
So I wrote, and it also does fancy stuff like the slash character, not okay, so thing.
Oh, that's cool.
Spaces are not okay, so
What are these S functions you keep
programming languages, C doesn't have it.
talking about?
It's literally 56 lines of code.
Yeah.
It's like it wasn't even. Some of this. It's just not. Oh, this is a new trick. If you're doing this sort of stuff a lot and you're writing fixed size buffers, then having like a check length macro that you just. Which function?
I don't know. You mentioned them. Maybe I'm imagining things. Never mind. I probably misheard. So
Okay. So what I'm saying is this check length macro is actually super useful. Basically, it just keeps track of how much buffer space you have.
yeah. Oh, it's a macro. Oh, duh.
Spread F returns the length, right? So you can use
F.
the macro to just add the number of
Oh yeah.
used, and then if it fails, then returns.
Yeah.
So I use this sort of stuff all the time for checking that to make sure I don't overlap the buffer. Usually I just assert if I do, because it's just
Right.
but I do that sort of like local macro stuff.
That's pretty cool. Yes.
The idea is like, so it's 250 lines of whatever this 240 of this like meta code where I just
Yeah.
these types, and then it just generates like there's not very many types right now. Right? Just get each type adds more than it adds some sort of exponential amount of generated code, and then these are just these de facto is just function prototypes.
Right.
And then in another file, I could do it in this file, but for other reasons I don't. And basically, I can just write
Yeah.
I'll get 100% type safe.
That's pretty cool. Nah, it's okay.
Makes it annoying. But if you're interested, I can just paste like this, which is
I got the idea.
type and they're like the meta language and then the actual I just want the code generator. It's not just the same problem. One of the reasons it's so short is because it uses a lot more. I don't know if anybody can actually know that that's my code is
One of my habits recently has been to write single file style so that code has no dependencies and can be moved to new projects easily. It's cool. I'll watch your stream tomorrow to see more. For the time being, I am getting tired.
Yeah, I do think single file style too, so they have no dependencies. Nothing of my shit. I don't even depend on the frontend library anymore.
Yeah.
But everything depends on this single file STD image,
Right.
and it's like 700 lines, which is crazy shit. So all of I have dependency on this.
Yeah. All right. And my stream is ending because I'm tired. Where was chat? Here it is. I'm usually in bed by like 9:30. I'm starting to get sleepy, so I'm going to start winding down. But thank you everybody for coming and watching. I had a great time. And the best part was when Sean completely took over my stream and showed us a bunch of awesome stuff. So that was really cool. Next week, same time, same place. I'm trying to get past this reflection stuff because like I've already written most of the interesting parts and the remaining code is pretty boring. You know, writing print statements and stuff. Yeah, basically. So hopefully I can finish all this stuff by next week, and I want to get back to my render, and we'll be working on my render and stuff, which may be a bit more interesting because I don't know a lot about renderers, and I'd like to know more, which is why I'm writing one. So we'll see. It'll be fun. And now this stream is ending too. Sorry, Pixelark. Sorry, party's over. Everybody go home. So anyway, where's OBX? Thank you, everybody.